All right, this is the key to the quiz that you just took. In number one, you're given the graph of a function, and you're asked to find the domain, range, f of 3, and f of negative 5. All right, so remember the domain is the set of x coordinates. So first of all, notice that this is an arrow, so that part of the graph keeps going down like this, and then this is an open circle. So remember this point here that you see, and this you can't see it well, but let me go ahead and use this one. So that point right here, which is 6, 9, so this point 6, 9, since that's an open circle, 6, 9 is not on the graph. So that means that 6 is not in the domain, okay? All right, so the x value 6 would not be in the domain since that's an open circle. The same thing for the y value of 9. So 9 would not be in the range. So remember, the domain is a set of x coordinates. So if you look at all these, and always go from left to right. So if you look at all these points on the graph, the question is, what are the x values? Okay? And the same thing for the range. If you look at all these points on the graph, what are the y values? What's the interval consisting of the y values, and what's the interval consisting of the x values? Okay, so when looking at the domain, the best thing to do is to go along the x-axis like this from left to right. Now remember, this is an arrow, so it keeps on going. So if you look at this right here, this arrow keeps on going like this, right? Okay, so you're going from negative infinity. So every point along the x-axis where I'm at. So this point's going to be this x value here, I should say. This x value is going to correspond to a point in the graph. This x value is going to correspond to a point in the graph. This x value is going to correspond to a point in the graph. In fact, you're going to go from negative infinity, because remember this arrow keeps on going like this. So you're going from negative infinity all the way to, and then when you go across like this, so every x value here, every x value is going to correspond to a point on the graph. So you keep on going all the way, and then this is where the graph stops right here. There's no arrow, so that's an open circle. That's where it stops, and that x value right here is 6. Okay, so you're going from negative infinity all the way to 6, and since that's an open circle, you're going to use parentheses because 6 is not in the domain. So meaning this, when you put your answer here, you're going to say negative infinity to 6 with an open circle. Okay, so 5.99999, when x is 5.999, there's a point in the graph. But when it gets to 6, exactly 6, that's an open circle. So 6 is not part of the domain. Same thing for the y value of 9. 9 would not be part of the domain of the range rather, because of this open circle. So let's look at the range then. So the range, remember, is a set of y coordinates. So when you look at all these points on the graph, remember it keeps on going like this. So when you look at all these points on the graph, what are the y values? What do the y values consist of? All right, so to determine the range, you go along the y-axis from bottom up, because remember, intervals, you always go from um, when you talk about intervals, you always go from smallest to largest. And so when I do that, notice that this part keeps on going, right? So you're going from negative infinity all the way, and notice that all these points here is going to have a y value going from negative infinity all the way to, and then this is where the graph stops, and the largest y value you see here is 9, but 9 is not part of the range because of the open circle, so we have to use parentheses. So you're going from negative infinity to 9 with parentheses. All right, now remember, infinity, negative infinity, regardless of whether this was a closed circle or not, with infinity, negative infinity, you're always going to use parentheses. All right, f of 3, so remember what f of 3 means is what is the y value when x is 3? Because remember, this is x right here, right? X is 3. So when x is 3, so locate, so this is on the x-axis, this is where x is 3, but the point corresponding to it is right here. So let's label that point. That point is 3, comma, and then that's a 7. So the question is, when x is 3, what's the y value? The y value is 7. So the answer here is 7. Same thing here. What is the y value when x is negative 5? So let's locate the point of the graph where x is negative 5. So here's x is negative 5. The point of the graph corresponding to it is this right here. If you label that point, which is helpful, that is, oops, that's the wrong one, sorry. That's negative 6. Here's negative 5, sorry. Negative 4, negative 5. Negative 5, the point corresponding to it is right here. So that is negative 5 comma negative 3. All right, so when x is negative 3, my y value, I'm sorry, when x is negative 5, my y value is negative 3. So negative 3 goes here. All right. Now, in number 2, you're given a piecewise function, and you're told that f of x is equal to 4x minus 1 if x is greater than 2. Now, if x is less than or equal to 2, then my function is equal to 2x plus 1. So these are the different pieces, so to speak. So the question here is, same thing like we discussed here, what is the y value when x is 5? So you got to locate which of these you're going to use, right? You're only going to use this if x is greater than 2. And you're only going to use this one if x is less than or equal to 2. Well, over here, x is 5. Well, since x is 5, 5 is greater than 2. So I'm going to use this one. So you're going to say 4 times 5 minus 1. So that's going to be 20 minus 1, which is 19. So my y value when x is 5 is going to be 19. Same thing for f of 2. So I have to determine when x is 2 which of these I'm going to use. So notice this is the one right here that says x is less than or equal to 2. So that's where x equals 2. Don't use this one because this says you use this one only if x is greater than 2. Here x equals 2. So you're going to use this one. So you can say 2 times 2 plus 1. So that's 4 plus 1, which is 5. F of negative 1, that's going to be this one again. Negative 1 is less than or equal to 2. So you're going to use 2 times negative 1 plus 1. So that's negative 2 plus 1, which is negative 1. All right, so that's A, B, and C there. And then in letter C, number C rather, you're given the function, like this quadratic function, and you want to find the average rate of change in the interval from negative 3 to 4. So remember, the average rate of change is kind of like the idea of slope of a line. So the way to do that is you're going to say the average rate of change. All right, so remember the idea of slope, you put the y coordinates in the numerator and the x coordinates in the denominator. So if you think of this interval right here, if you look at this value when x is 4, okay, when x is 4, you're going to say g of 4 to find the y value, and you're going to subtract, because remember slope you subtract, right? y2 minus y1 divided by x2 minus x1, you subtract. So the y value corresponding to 4 is this one. You're going to subtract the y value corresponding to negative 3. So that's what you're going to put in the numerator. And then the denominator, you're going to say 4 subtract a negative 3. Keep the order. Since you started here, you're going to start down here. So you can say 4 subtract a negative 3. And then you got to find what g of 4 is and what g of negative 3 is. So you got a little bit more work to do. So g of 4 means I go to my function g, and wherever we see the variable x, I substitute 4. So I get 2 times 4 squared minus 3 times 4 plus 1. All right, 4 squared is 16, right? So you got to do the order of operations. Don't say 2 times 4 is 8 and square that. You know that's not the order of operations. So you got to use it. You got to do exponents first. 4 squared is 16. 16 times 2 is 32. Minus 3 times 4 is 12, and then plus 1. 32 minus 12 is 20, and 20 plus 1 is 21. All right, so g of 4 is 21. Now, let's go ahead and find g of negative 3. So same thing, wherever I see my function x, I'm going to substitute negative 3. So I get 2 times negative 3 squared minus 3 times negative 3 plus 1. Negative 3 squared is 9. 9 times 2 is 18. A negative 3 times a negative 3 is a positive 9, and then plus 1. Okay? And then when you add those up, that's going to be 28. Okay, so now we're going to substitute g of 4, which I just found to be 21. So you can say 21 subtract g of negative 3, which I found to be 28, divided by, and remember 4 subtract a negative 3 means 4 plus 3. So the numerator is a negative 7, the denominator is a positive 7, and if I reduce that, I get negative 1. So the average rate of change is negative 1. Average rate of change is negative 1. Okay? So basically, if you think of this as a fraction, negative 1 divided by 1, for each 1 unit change in x in the x coordinate, the the y value decreases by 1. That's what that means. All right, so the y divided by x. All right, so that's it. So that was the key to the quiz that you just took.